Okay, good afternoon. This is Ahmed today with some questions. Today is July 18, it's 2022. And the first question is that a firm, so that's question number one. And the question reads that a firm has a manufacturer production according to this following function, and the function is F is equal F, Q is equal F of K of L. These are the two arguments that we have, and then the function, the objective function is K to the power of 3/4 and labor to the power of 1/4. So this is the objective functions that we are giving. And then we are asked to series of questions, and we were asked to solve these questions or answer this question. This question is asked is part A of the question, where it says calculate the average product of labor, which is the average product of labor, when the level of capital is fixed at 81, where K is equal to 81, and this is a fixed unit, and the firm uses only 16, where L is equal to 16 units of labor. And then the question continues, how does this average product of labor changes when the firm uses L is equal to 156 units of labor? So there's a series of questions that we need to answer here. And the first one is to answer this question is, we need to substitute these numbers into these equations that we are giving to find or calculate the level of Q that is produced using 81 units of K and 16 units of labor. To do that, just go Q is equal to, we have K, we know that this is 81, and then the power of 3/4. And also the level of L that we need to use is 16 a unit of L to the power of 1/4. And then when you do the calculation and then you solve this one, then you will get actually a number 44. Also, we know that APL, average product labor, is equal to Q/L, and therefore we have 54/L is 16, and therefore that is equal to 3.375. Now, the second part of the question is asking, since K is fixed, means the level of K unit does not change, but then is asking what will happen if you keep K constant. I mean, K doesn't change, it's 81 unit, and then you change the level of labor from 16 to 256. And then again, simply what we do is that we calculate first the level of Q, and then K is, as we said, it doesn't change, 8 to 3/4. And then we have 256 to the power of 1/4, and that is equal to 108. And therefore, to calculate APL, and that is equal again Q/L. We calculated Q to be 108, sorry, and the level of is 256. Therefore, that will be 0.422. So that's the first part of the questions. And since I need some space, I'm going to move to the next one. Part B of the question is asking, they're asking if find an expression for marginal product of labor, which is the MPL, for part B, asking you to calculate the marginal product of labor when the level of capital is fixed. So where K is equal 81, that's fixed. And then illustrate that the marginal product of labor depends on the amount of labor hired. By calculating the marginal product of labor for 16 and 81 units of labor, where labor is first is equal to 16 and then labor is equal to 81 units. So that's what the question is asking us to do. To find the expression for the marginal product of labor, we need to take the derivative of the functions that we have Q with respect to L, with respect to labor. When we do that, then we either, this is equal to marginal product of labor, so that's all equal. You can either write a marginal product of labor or taking the derivative of the function, the production function with respect to L. And then if we do that, then just mind you that the function of Q is equal to K to the power of 3 over 4 L to the power of 1 over 4. So we're taking the derivative of this function with respect to L. And then when we do that, then we are taking the derivative, the whole function, because that's a product. And therefore we I'm just going to write it here. So it's 1 over 4, and it's K to the power of 3 over 4, and L, that should be minus 1. And then if you do that, that's minus 3 over 4. So I hope that this is simple and easy for you to take the derivative. So that's our MPL. Now, what we do is that we are going to substitute our numbers. When we do that, it's 1 over 4 to the 81, 3 over 4, and then L to minus 3 over 4, all this is equal to 27 over 4 times L to the minus 3 over 4. So that's the function. Now, we were asked that when L is equal to 16, what will be the marginal rate of product for labor? So the marginal product of labor is equal to 27 over 4 times L is equal to 16, and then raised to the power of minus 3 over 4. And when we do that calculation, then that is equal to 0.844. Similarly, when L is equal to 81, because we were asked to compute marginal rate of products by changing the level of L from 16 to 81 and see what happens. So now marginal product of labor So when L is equal to 81, then all we have to do is just instead of 16, substitute 81, and then we'll get, so marginal product of labor is equal to 27 over 4 times 81 to the power of minus 3 over 4. By calculating this one, then you will get 0.25. So it's 0.25. You need to justify your answer. And by justifying your answer, we mean that you need to explain that what is the difference. If you change the level of labor, what will happen? Therefore, we can say that as the number of units of labor higher increases, the marginal product of labor decreases. from 0.844 to 0.25. So we say that marginal product of labor when we had only employed 16 units of labor was equal to 0.844, and that is greater than 0.25, which is equal to marginal product of labor when we have employed 81 units of labor. And this is holding the level of capital. Fixed at k equals to 81. So this is how you answer this question, and this is how you justify your answer for, and then the situation when you're writing the midterm or the exam, and then you see this question. The second one is going to be question number 2. And question number 2 is a Leontief production function. So a firm production function is equal Q equals F of K and L, and that is equal to min for K8L. So that's the production function. Part A of the question is asking how much output produced, like how much output produced when K is equal to and L is equal to 3. So that's the question that is asking. Firm's production function, we say that this is a Leontief production function. By Leontief, we mean that this is a model of fixed proportion. So this model is a fixed proportion or Leontief production function. What do we mean by this? So we have Q, f of K, f L, we have 2 arguments, and that is equal to the min, and that's 4K and 8L. So this is a level of capital output, inputs, and this is a level of labor input. And we can see that this is where labor and capital enters a complements. So this means that the fixed proportion, an amount we are going to produce, is minimum or limited, or in other words, are constrained by either level of K or level of L. So the amount of machine, which is K, available, and the amount of labor available. So this is what it says. That's the level of machineries, for example, it's available, and this is the amount of labor that is available. So here, this 4K8L means that we we need 8 units of labor for 4 machines. For example, just simplify it. And this means that if we have too many of either one, either too many of capital or too many of labor, either one of them, we will not be able to produce as much. And this is what the min means. So if you have too many of this or too many of that, then we will not be able to do this one. So let's say, for example, you have too many machines, but you don't have the labor to operate this machine, or you have too many machines, but you don't have enough labor. And therefore that min means that it's a constraint. And constraint means that if one of them is more than other, like let's say in terms of we have too many of capital and not enough labor, or we have too much labor, not enough machines, then that means that we will not be able to produce as much. So that's what we mean by Leontief fraction function. I hope this one helps just a little bit. And again, the goods that we have, the labor and product, they are entering a complement. So when the question they're asking in 1K is equal to, and L is equal 3, then we can see that the quantity is equal to 8 units. It is because, as we say, this is a Leontief production function, and in which the inputs are used in fixed proportion. So we have established this one. Using 2 units of capital, so by using 2 units of capital, and by using 2 units of capital, we have 4 times K times 2, that is equal to 8. And using 3 units of labor, which is 8 times 3, that is equal to 24. Units of C, that yields 24. So the minimum of the two, is 8 units. So the minimum is 8. Therefore, that is equal to quantity. And so that is the most output. This is the most output that can be produced with this level of, you can call it a technology. So that's for first part of the question. Now for part B of the question, it's asking if the wage rate is $60 an hour, and the rent, which is R, is equal $20 an hour. So what is the cost minimizing input mix for producing when Q is equal 8 for 8 units of output? So the cost minimizing mix of K and L produced, we say Q was equal 8. And this is where K is equal 2 and L is equal 1. If the wage rate is $60 an hour, and the rental on the capital is $20 an hour, rentals on the capital is $20 an hour, then the cost minimizing mix of K and L that produces 8 unit where Q is equal 8, SK is equal 2, and L is equal 1. This is because the Leontief, again, this is because the Leontief function dictates that only 8 units can be produced, so only 1 unit of labor, is necessary to produce this amount to go along with the 2 units of a capital that get this minimum. So again, if the wage rate is $60 an hour and the rent rate on capital is $20 an hour, so the cost minimizing mix of capital and labor that produces 8 units of that good would be K is equal 2 and L is equal 1. So 2 units of capital and 1 unit of labor. And this is because the Leontief production function dictates that only 8 units can be produced, so only 1 unit of labor is necessary to produce this amount to go along with the 2nd unit of capital that get this minimum. So that's your answer to part B. And then for part C of the question, the question is asking, how does your answer in part B changes when wage rate decreases to $20 per hour? So wage, instead of 60 now, it's $20 an hour. So what happened? So since K, capital and labor, are perfect complement, in the production process, so the cost minimizing levels of K and L do not depend on the rental of capital and labor. Therefore, the cost minimizing level of K and L do not change. With changes in the relative rental rates. So that's part C of the question number 2. And then let's move to question number 3. So it's question number 3. So on question number 3, a firm has a function that I can see it's a perfect substitute. So we have a firm's production function. Function is equal Q is equal F of K and L, and that is equal to 4K plus A to L. And the question is asking that how much, part A, how much output is produced when K is equal to and L is equal to 3. So now to answer this question, we know that Q is equal 4 times 2 plus 8 times 3, because that's the level of labor and that's the level of capital. Where you do this one, that's 8 and 24 is equal to 32. So 32 units of. So that's the first part of it. Now, for the second part of the question, so how much output is produced when K is equal to 2 and labor is equal to 4? So the level of output, you're using 2 units of capital and 3 units of labor, we were able to produce 32 units of that output. So by giving this level of capital and labor inputs. For part B, if the question is asking if the wage rate is $60 per hour and the rental rate is $20 per hour, what is the cost minimizing input mix for producing 32? Q is equal to 32. It's a very similar question than the question before. The only problem is that this is a substitute, and the other question number 2, it was a Leontief production function where we had a complement. So that's the different that we need to work it here. So we know that the marginal rate of technical substitute of K of L is equal to 8/4. How do we know that? We know that because we know from the equation that marginal rate of expression of Sk of L is equal marginal rate of T of L over marginal rate of T of K, or that is equal to MPL over MPK. So that's the means. So from here, 8/4, that is 2. So this means that the company can trade 2 units of capital for every 1 unit of labor. And this production function does not exhibit diminishing marginal rate of technical substitution. So marginal rate of technical substitution. So by looking at the function that the production function is giving, we have 4K plus 8L, sorry, that's 4L. Then marginal rate of technical substitution, we say the marginal rate of technical substitution for K and L is equal to the marginal product of labor over marginal product of capital. So what we need to take the derivative of this cube first with respect to K, then with respect to L, and then we sum it here. And that is equal to Q over L is equal to marginal product of labor, and also taking the derivative of Q with respect to K, that is equal to marginal product of capital. So that's how we do. Now, if we take marginal product of capital, labor, then that is equal to 8, and then marginal product of capital, that is equal to 4, because the derivative of 8L of this function with respect to L is only 8, and also 4K is 4, and therefore marginal rate of technical substitution is equal to 2. So marginal rate of technical substitution shows the relative relationship between inputs and the trade-offs among them without changing the levels of the total output. When using common outputs such as capital and labor, which we use it here, the marginal rate of technical substitution can be obtained again using this equation. So now, as I said before, that this function that we have is a perfect substitutability between capital and labor. So this means that only one input will be utilized. So we know, since marginal product of labor over wages is equal to 8 over 60, that is less than the marginal product of capital over rent, which is 20. Marginal product of capital over all, which is the rent, is equal to this. So what does this mean? This means, this expression means that the company should hire all capital to get 32 units of output. This will require this will require 8 units of capital. 8 units of capital. For perceive the question, is it asking if how does your answer in part B changes when wages rate decreases to $20? We said that the rate of the wages was $60, but then now it decreased to $20. So it is reduced to $20. So what happened? Similarly, you can say that here we have marginal product of labor divided by wages, and that is equal to 8, and the wages now changes from $60 to $20 an hour. And still, it's greater than 4 over 20, which is equal to marginal product of capital over rent. So the company should hire only labor. We're looking at this. The company should hire only labor to get 32 units of output. This will require 4 units of labor. So that's question number 3. Let's move to the next question, to the next page, because I need probably a little bit more space. And I'm just gonna do this question really quick. That's question number 4. Question number 4. A reason an electronic plant's production function, the production function for electronic plants is equal to 5L and K. That's the production function, where Q is the output and L is the amount of labor and K is the amount of capital. So this is the amount of labor per period. And K is the amount of capital used per period. So that's the amount of capital used per period. The price of labor is $1. Whereas price of labor is $1, and the price of capital is equal to $2. So these are the price of labor and capital, and that's per unit. That's per unit. So the firm's vice president for manufacturing hires you to determine which combination of inputs the plant should use to produce 20 units of output. Means that they are setting a target of a production in terms of quantity, and that's equal to 20 units of output per period, 20 units of output. And that's again per period. So in terms of period, it doesn't matter. Period could be every shift of 8 hours, or every period could be every 15 minutes, every 1 hour, every 2 hours, every day, every week. It depends. It's open for a interpretation. And so period means it's a period of time, and that depends on the length of the time that you want to set for this target. The first part A of the question is asking what advice would you give him? So you're hired and you're asked to advise. Advice would you give him? So before you do the advice, you need to find the contingency condition for labor and for the product, for marginal product and marginal labor. And then after that, you find the constraint, and then you will say what should be the optimal level of these capital and labor to meet this target of producing 20 units of capital per week or per period. So tangency condition. So the tangency condition is we have marginal product of labor over marginal product of capital. By definition, that is equal to the price of labor over the price of capital. This is the contingency condition. But we also have that marginal product of labor over the marginal product of capital is equal to 5 units of K over 5 units of L. And that is equal to the proportion of K over L, or labor capital over L. And that is equal to the price of L equals to the price of K. And we know that the price of L is $1 and we know the price of K is $2, which is equal to 1.5. So now here we have another tangency condition. So the tangency condition is equal capital over labor and equal to the price of labor over capital is 1/2. By cross multiplying, we can get that L is equal to K. So how we got this one? Just we cross multiply 1 time L, 2 times K. So L is equal to K. Let me move to the next page so I can have more room and then you can see it clearly. So now the output constraint, is such that 5L of K is equal 20. And what we do is that we are substituting L equal to K right here. So we have 5, L is equal to K times K, and that is equal to 20. So 2 times 5 is 10, K times K is K squared, and that is equal to 20. So it's a simple solving this one. So it's K squared is equal to 20 over 10. And therefore K is equal to the power 2 squared, and K is equal to root square of 2. Or you can write this as K is equal to 2 to the power of 1.5. So it's same thing. Substitute K is equal 2 to the power of 1.5 or root square of 1.5. So this is the level of K. Then you will calculate that the level of labor is required would be 8 to the power of 1.5. So this is the optimal input mix. This is the optimal input mix. So what advice do you give? You would give the manager an advice that in order to meet the target of producing the amount of 8 units of quantity per period, then the optimal units of capital required is 2 to the power of 1.5, and the optimal level of labor is required is 8 to the power of 1.5. So that advice that you will give to the manager. For B, suppose the price of labor increases. So, and that's equal to $2. Before the price of labor was $1. What effect will this have on output per unit of labor? So what effect would this have on output per labor? As we did in part 1, so the optimal input mix is given by the tangency condition. So this one is the optimal input mix just capital of labor given by tangency condition. And that is K over L. That is equal because it's 2 over 2, and that is equal to K over L, and that's equal to 1. So, well, this implies 1 over 1. So we have K is equal L. That's the condition. Same thing that we did in part A. We now again substitute L for K. And we do 5. K times K is equal to 20. 20 units we want to produce. So that's 5K squared is equal to 20. And then K squared is equal 20 over 5, that's equal to 4. Therefore, K is equal to, because the root square of 4 is equal to, so. Since K is equal L, therefore L is equal to as well. So the output per unit of labor, so the output per unit of labor increases from 20 to the 8 power of 1.5 to 20 over 10, or 20 over 2, sorry, which is equal to 10. So 20 over 2 is equal to 10, because that's the level of capital and labor we have. So therefore, that's 10. So this is your answer, and see you next week. See you on Wednesday. Thank you.